Greetings, Detectives. Mrs. McKay here, and let's go ahead and get started on Clue 9-4. We will start by writing in our learning target blanks. I can use slope to determine whether lines are parallel or perpendicular. I can use slope to determine whether lines are parallel or perpendicular. Now, before we do anything, let's do a quick review of some vocabulary and introduce you to some new vocabulary. First of all, parallel. Let's remember what parallel means. Can you tell me? That's correct. Parallel lines are two lines that never, or two or more lines that never cross. They always remain in equal distance from each other. Okay, like railroad tracks. And we actually have a symbol that we use for parallel lines when we want to say that one line is parallel to another line, or one line segment is parallel to another line segment, and it's actually two little parallel lines that are standing straight up. Okay, so that's one thing that we need to remember. The other thing about lines is the idea of perpendicular lines. Perpendicular lines. What does that mean? Do you know? Well, perpendicular lines mean that you have two lines that make, when they meet, where they intersect, they make a right angle. They make a right angle. So here would be two perpendicular lines, and they make a right angle. Okay? And the way that we show that when we want to say that one line is perpendicular to another line is we use this symbol right here. Basically a little upside down T, which is making that right angle. Okay? Now, another thing that we want to talk about are horizontal lines. Horizontal lines. Well, horizontal lines you see often when you're graphing a line. A horizontal line is a flat line that is parallel to the x-axis. Okay, it's parallel to the x-axis. And that means that all horizontal lines are parallel or perpendicular. What do you think? All horizontal lines, are they parallel to each other or are they perpendicular to each other? Well, they're parallel, aren't they? Okay, and the other thing that we say about horizontal lines is we recognize the type of how we write that line. So if we wanted to say that the equation of a horizontal line never really has an x, it just has a y. Y equals 3, or y equals -7. And all that means is when you look at a graph, if we say y equals 3, it says no matter what x is, y equals 3. If x is 7, y equals 3. If x is -4, y equals 3. And you can see that it just, y equals 3 is where we go up 3 on y and we just create a horizontal line. Okay? Vertical lines are just the opposite. Vertical lines are straight up and down lines that are parallel to the y-axis. And the way that we write an equation for a vertical line is we write x equals 7, or x equals 3. Okay, so if I had x equals 7, 1, 2, 3, 4, 5, 6, 7, then that means that no matter what y is, x is always 7. Okay? Doesn't matter what y is, x equals 7. So those are horizontal and vertical lines. Let me ask you a question. Do you think that a horizontal line is perpendicular to a vertical line? Think about that. Are horizontal lines perpendicular to vertical lines. Tell me what you think about that. Okay, well, they are. They are always perpendicular. They're always perpendicular. So that's an important thing to know. The last thing that I want to just quickly mention to you is the point-slope form. The point-slope form is similar to the slope-intercept form. So slope-intercept is y equals mx plus b, isn't it? Where the y and the x are your variables, the m is your slope, and the b is the intercept, the y-intercept. Point-slope form is a cool little version that you can use if you're wanting to quickly find the equation of a new line and you're given a point. And what that means is you take a point. So if I say to you, tell me the equation of a line that has a slope of 3 and it goes through the point 1, 4. Then what I can do is I can take this information, m equals 3, and the point 1, 4, and I can actually plug it into this point slope form, and I can say y minus the y1 value, which is the y value of my point, so y minus 4 equals m, which is 3, times x minus the x value of my point, x1 sub 1. And then I can just do a little work by simplifying, and I can get it into slope-intercept form. So let me show you what I mean. So I have 3 times x minus 1 would become 3x minus 3, y minus 4 equals 3x minus 3. I'm going to add 4 to both sides so that I get my y by itself, and I end up with y equals 3x plus 1. And there I've just done it. I've created a line using the slope of 3, and that point 1, 4 is on the line. And I can double check that by simply replacing the y for 4 and the x with 1. And I can say 4 equals 3 times 1 plus 1, and it should become a true statement. 3 times 1 is 3, plus 1 is 4. 4 equals 4. So there you have it. So that's just a little quick thing to help you know a little bit about point slope form. We're going to use it later in this video. Okay, let's move on. Now, we're going to talk a little bit about parallel lines and perpendicular lines, and we're going to discover some things. We're going to review some things and discover some things about the slope. Because if we know the slope of lines, we can decide whether they are parallel, perpendicular, or neither. So let's first talk about these two line segments that I have, PQ and RS. Can you do me a favor and tell me what the slope of PQ is? Well, the slope of PQ is rise over run. So here's one point to this point, right? And I'm going to go up 1, 2. So I'm rising 2, and I'm going over 1, 2, 3, 4, 5, 6. So the slope of PQ is 2 over 6, or I can reduce that to 1/3. Okay? Now let's talk about the slope of RS. What is the slope of RS? Again, I'm going to go up 1, 2, and over 1, 2, 3, 4, 5, 6, and my slope is 2/6 or 1/3. What do you notice about the slope of parallel lines? That's exactly right. Parallel lines have the same slope. They have the exact same slope. And that kind of makes sense, because what did we do with our line? If we have a parallel line, it's really just been translated vertically. It's moved up or it's moved down, hasn't it? Even if we moved it side to side, it still would remain parallel. The slopes would remain the same. So our parallel lines have the same slope. That's an important thing to remember. It's very helpful when you're asked to do some work with parallel lines. So remember, parallel lines have the same slope. Now, let's talk about perpendicular lines. Let's see if we can figure out what the slopes of these line segments are. NU is our first one. So go ahead and figure out what the slope of NU is. Well, you went up 1, 2, over 1, 2, 3, 4, 5. So the slope of NU, line segment NU, is 2/5. Now, tell me what is the slope of F, line segment FU, or UF. What is the line segment? Or what is the slope of that line segment? Well, this time you went down 1, 2, 3, 4, 5, and over 2, 1, 2. So it's actually -5 halves. I want you to take a look at the two slopes, the slope of line segment NU and the slope of line segment FU, and tell me what are some things that you notice about those two slopes. What do they have in common? What do they have different? Well, I hope you noticed that they both have the numbers 2 and 5. They're just flip-flopped, aren't they? One is 2/5 and the other is 5/2. So they're really reciprocals of each other. A reciprocal is when you multiply a number times its reciprocal, you always get 1. And if we did that, if we multiplied 2/5 times 5/2, we'd get 10/10, which is 1. 10 over 10 is 1. But there's one other thing that you should have noticed besides just the fact that they're reciprocals. What is it? Well, it's that one is a positive number and one is a negative number. So here's the thing that you need to know about perpendicular lines. Perpendicular lines have slopes that are negative reciprocals. Negative reciprocals. And that means that we take the reciprocal of the slope and we make it be the opposite, or the negative. So one is positive and the other is negative. So you'll really want to remember that. Negative reciprocals. They're like the complete opposite. Everything's backwards on them. Okay? Now that we have that information, we can actually use what we know about perpendicular and parallel lines, and we can predict whether a line is whether lines are parallel, whether they're perpendicular, or whether they will intersect at some point and are not, even though they intersect, they're not perpendicular. So parallel, perpendicular, or neither. Why don't you try this one? Okay, so now let's do a little bit more work with parallel and perpendicular lines, but this time let's see if we can write some equations of lines. So our first question says, write the equation of a line, should be of a line, that is parallel to y equals 3x minus 4. And it passes through the point 1, 2. So if we know that the line is parallel to this line, what do we know about the slope of our new line? Because we're going to be writing the equation of a new line. I'm going to write here y equals mx plus b, so that we know that we're going to have to find the slope of this line. So tell me, what is the slope of y equals 3x minus 4? The slope is 3. So that means our new line is going to have a slope of 3. Now, we have two different ways that we can solve this. We can say y equals 3x plus b, and we can try to figure out what b is, and it looks like we need to come back for part 2.